In this video, we will discuss how to get started using the ATTiny85 in Arduino IDE. What I have here is a little microcontroller development board which is a Digispark ATTiny85 development board of Digistump. And when compared to Arduino Uno, it's been there in my bins for some time. So I decided to give it a try. It has 6 GPIO pins which can be available in pin headers here. It can be powered through USB or on external power supply through onboard 5 volts regulator. It has power LED indicator in green color which indicates if the board is powered. This is the power indicator. And it also have another LED in red color, which this one, which is a user LED, which we are going to use for the example later on. It is capable of 3 hardware PWM outputs, suitable for controlling motor speed or for dim light control. It has 4 channels of 10-bit ADC or analog to digital converters for reading sensor values. It has a surface-mounted ATTiny85 microcontroller, which is this one, while this one is the voltage regulator. ATTiny85 is an 8-bit AVR microcontroller based on RISC CPU. It has a programmable watchdog timer for resetting the microcontroller in case it hangs up. It has a total of 8 kilobytes of flash program memory. Digispark ATTiny85 uses micronucleus Tiny85 bootloader. The bootloader occupies around 2 kilobytes of flash memory. It has 512 bytes of memory space for EEPROM and another 512 bytes for the RAM. It comes with a single port named PortB, which has 6 GPIO pins, which are all bidirectional, meaning it can be configured either as input or output. Each GPIO pins has configurable internal pull-up resistor and an interrupts capable. It has 2 8-bit hardware timers. It is capable of I2C and SPI but no UART. Operating voltage is from 1.8 volts to 5.5 volts. And it can be clocked up to 20 MHz. You might ask, why use ATTiny85 instead of a regular Arduino board? It is because it is smaller, so it occupies less space or footprint. It is low cost or cheaper compared to full-fledged Arduino development board. It is low power. It consumes a minimal amount of power. It can be powered through a coin cell battery which fits for battery-operated projects. It is ideal for projects that needs a very few GPIO. Another cool thing about this board is it can be programmed using the familiar and beginner-friendly Arduino IDE. So enough of technicalities, let's begin by installing the USB driver and prepare the Arduino IDE. So let's install the USB driver from this link. I will provide the link in the video description. Look for digistump.drivers.zip if you are using Windows. I already downloaded this one, so you need to just download the digistump.drivers.zip. Save. So I will just go to my desktop and I will just unzip it using a 7-zip. Just open this one, go inside the Digistump drivers, And since I'm using a 64-bit Windows, I will install using the dp install 64.exe. Just say yes, then next. And if the status are all checked, it means you successfully installed the USB driver for the ATTiny85 development board. After that one, we need to add the board preferences in Arduino IDE by clicking the File menu, select Preferences, and in additional board manager URLs, if you already have a previous and if you already have previously installed another board, you just need to add a comma here and put this link. Then hit OK. After that one, we need to download the board manager for the ATTiny85 by clicking the Tools menu, select Board, and click Boards Manager. In the Boards Manager search box, type Digistump. And install the Digistump AVR boards. I already installed this one, so I don't need to install it. After that one, you can close it. To get started, we can use the regular example in Arduino IDE by clicking the File menu, Examples, Basics, and click the blink. And let's just define a pin assignment here. Let's call it LED pin, which is connected to pin 1. We can repair it in the Digispark schematic. And as you can see, the onboard LED is connected to PB1. Let's go back in the blink example. And let me copy the LED pin and change this object to LED pin. Let's save it. Let's call it blink ATTiny85. Hit OK. Let's upload it, or we can verify first. So as of now, it's 11% of the program storage space. Let me hit upload. And as you may notice, it doesn't automatically upload the program to the ATTiny85 because we need to log it in. So I will remove, then log it back. Okay. Micronucleus done. Thank you. And as you can see, the user LED, which is connected to PB1, port B1 is, or port B bit 1 is now blinking every 1000 milliseconds or 1 second. Now in case you decided to optimize the code, we can do it by using a direct port manipulation. Because as you may notice, we are currently using 11% of program storage space or 700 bytes. In using direct port manipulation, we need to understand and use 3 registers for accessing the GPIO, which are DDRB for setting the pin direction of the port. This will replace the pinMode function. PortB for writing on a port. This will replace a digitalWrite. And lastly, pinB for reading on a port. This should replace the digital read. We will also be using bitwise operation for setting and clearing of bits. For you to understand it clearly, let me comment it out, this one, the pinMode, and let's replace it with DDRB or data direction for port B. And as you know, LED pin is connected to bit 1. We just need to bitwise OR here and use the 0B 0000 5 6 7 8 colon. And since the LED pin is connected to bit 1, we just need to replace this one as 1. So this is the code for pinMode. So for the digitalWrite, for turning on the LED, we just need to use port B. And we will also use the bitwise OR. Like that. And to turn it off, we will use a bitwise AND using port B and equal 0B. Now we will use a logic high 1, 2, 3, 4, 5, 6, 7, 8. And to clear the bit, we just need to put 0. Let's save this one. File, save, compile. And as of now, it decreases the bytes from 700 bytes to 470 bytes, or from 11% to 7%. Let me upload it. Remove it and plug it back. Okay. And as you can see, the LED is still blinking every 1000 milliseconds. Let me change this one. Let's say 50 for us to notice the change in the code. Let me save it, Ctrl S, and compile. And upload. Remove. Put it back. And as you can see, the onboard LED is now blinking every 50 milliseconds. So that's all for now. Enjoy. I hope this tutorial helps you to get started playing with the ATTiny85 development board. And if you enjoyed this video, please give me thumbs up by clicking the like button and share this to your friends so that it can reach more people who might benefit from this. And if you are not yet subscribed, please do subscribe now. You might also like to visit my blog post at tech2tinker.blogspot.com for more details and references such as circuit diagram and source code. Thank you and have a good days ahead. I wish to see you in the next video. Bye!